Yeah. Yeah. But they sunk the USS. They did sink. Me, sure. Actually, it's they, what they say they thought it was, they said they thought it was, you know what? They even, but like, parents, I'm not saying, could die from that.
Hi, Nate.
Hey there. How's it going?
Good. How are you? Good to see you.
Good. How's the audio on this?
It's great. It's great. Everything is set up here.
Awesome. Right.
And can you also test sharing your screen so that you make sure you are able to
So she said that.
Okay. Give me a second so I can adjust.
So I have she does go by like an actual by you will buy Will Mac. Can you just back this? Your area. Oh look, we're on the screen. Isn't it? Oh yeah, the rules on the wall about like this. We're practicing on the cousin. Yeah, it's on Saturday. No, yeah. Yeah, no, I agree. Yeah, I'm straight bro. I know.
And can you stop sharing for a second and reshare your
Sure.
screen?
Huh? The mosque? No, I don't. The temple. Yeah, I don't go to the mosque. I go to the one that's in. I go to, there's two in Utica that I go to shit.
All right. Is that showing up for you?
Yeah, it's great.
Awesome.
Little do they know that I'm just a spy.
Let's see. I do. Yep.
Yeah, I remember I was in the field and I was praying over the TVs or over like that day, so in that rag that when he had sucks where like
Alrighty. And so, Cheyenne, I'll kind of have you. It sounds like I hear people pretty well, but I'll just have you, kind of be the, the input from the class. If people have their hands raised or whatever, I'm gonna try and make this as interactive as possible. So,
For sure.
perfect.
Oh, yes, I did see that. Overrun South 470. It was like posted. No way they didn't have. It was literally like it's out here. It wasn't right here. It was way down there with those. Yeah, you know, like. I don't know something about it. Static. Or is not even the road. They probably drove over a curve and was like, we're just hammering on it until they got down. Maybe. Why? Why is the question? Yeah, it's like barely cracked through. Yeah. Did you see it? I saw it. I saw the video you're talking about. I wasn't. Oh, yeah. Oh, yeah. Have you seen the? Bro, that shit killed. We'll go look at that shit. It always looks the craziest thing. It's just like so stupid. Yeah, like I it was like 20 video on Snapchat. Yeah, no, probably was yeah, we was an owl for that supposed. Yeah, they like spam the ESF 27, so like I didn't even. I couldn't stay out. I'm sorry, I went to the Syracuse one. Yeah, we did it there. So the idea is YouTube shorts. I'm so cool. I love YouTube. Good, how are you? Good. I feel like I read a few classes. Classes not me. I do. That's what the brigade chat spot. The brigade chat. I didn't know we had a gas lift.
Sorry, I always enjoyed the stuff here. That tour was really cool. Yeah, I didn't realize that there's that many systems going on in this vast building.
Yeah, and. Oh, you're right.
Hey, yeah, you be in the office?
Yeah.
Oh my God.
I
Put your deck nice.
Oh, my God. You have old name, by the way.
I must have the choice that she requested Joyce to put my next to her. Or she says, no one but Pat. She doesn't want to be next to. I'm like, yeah.
I don't really know. Is Pat? What is his deal here? I mean, I know he goes to work all the time. He interned or?
So, yeah, he interned with them, also at the end of the summer. Basically, his mentor was this guy, Bob, who like, typical, he's just like, nah, come on, like always made him work overtime and shit, and my mentor was just like this young, like, my little dude, you know, like in the suites and all that stuff and shit. Honestly, I wish I was in class with him because he learned a lot more than I feel like. But then after once the summer ended, they asked him to come in. What he offered to, I think.
I don't know.
If you go in for like 4-hour shifts, if you go in and like.
I would go, I mean, if I had that deal, that'd be awesome, running 4 hours once in a while.
He's definitely not working full days.
Yeah.
I remember last semester, I'm not going to work after this.
Working. Peter did that to you where you play work. My company was like, yeah, you're not doing anything. Oh, sitting in
So they got,
trailer all.
they were like, they were also like really nervous about like. With the interns, like we weren't allowed to like go on, do the reels we had on our side.
Oh, okay, yeah.
They do a lot of. They don't really go, they do like all the big shit pretty much.
That's what I was thinking.
Like turning stone, you know, they build all the rings, and they're doing all the renovations. Like all urban areas, like.
Okay, yeah, I see how they do stuff.
So like, you've been on for, you know, your guys and.
Yeah.
Factory, they don't, they do like, other stuff. They do,
I don't know if my company is. They use every business is different. Things like different.
I know, they have like classes,
Like I'm the type of.
I don't think they do that, I know they do stuff for,
Alrighty. Cheyenne, are we ready to kick this off?
Yeah, for sure. So let's
Alrighty.
short introduction. So class in
Go for
session now. Welcome back to mechanical and electrical equipment class. Today, it's a pleasure to have Nate Goodell. Nate is a distinguished engineer with expertise in building commissioning. And he is right now working for Tatum Engineering, a company that is based in Ithaca. So Nate is going to talk about building commissioning and gives us examples of the practices and experience that he got in this area over time. So this is super important because we are construction manager. So for our area, it's very important to understand the commissioning and standard practice for commissioning very well. So please welcome Nate, and Nate, it is yours.
Thanks. Yeah, and so this is going to be fairly flexible. I guess I want to make sure that we're covering information that's useful and interesting to you folks. And so if you've got questions, feel free to stop me. I've got more slides than I need probably. And so depending on what seems to be of interest, you know, we can take deeper dives into different areas or skim over stuff. I guess to start off with, who's heard of commissioning before? No one? Okay. So that's useful. And actually, that's a big reason why I put this presentation together in the first place. This is actually kind of a combination of a couple different presentations I've done in the past. A big part of it is one specifically for college students, and kind of the goal is a real high level introduction, but also just, you know, when I was in college, I didn't even really realize that HVAC, you know, building engineering was a thing. You know, I was a mechanical engineer, and we were real focused on production, you know, manufacturing, you know, gizmos. The way I got into HVAC design was one summer I was looking for a job, and I walked into a place that had mechanical on its name. Yeah, it turns out they did, you know, building design, ductwork, HVAC equipment. So this is, you know, at least partly just to say, hey, there's this thing out here, you know, take a look. It might be for you, it might not be, but you never know what your options are until you've seen what's out there. So again, this outline agenda is going to be fairly flexible. I do have something like a test at the end. See what you catch. Try and pay attention, and the more attention you're paying, the more you're going to catch, and the more you're going to get out of it. But you know, also obviously, like, pay attention in a way that you're actually absorbing the information, right? Notes only help if you're actually absorbing what you're writing down. Anyways, let's get started with, you know, what commissioning is. So it started with ships, and you know, I guess there's a reason it started with ships. If you're thinking about it, you know, what's special about a ship? Anything?
Can you repeat the question?
Sure. Yep. So what's special about a ship? You know, what's different? What different circumstances might drive them to come up with commitment? You know, I guess we haven't really defined commissioning yet, so maybe that's an unfair question. But what I'm looking for is ships go out to sea, right? And when you're at sea, you don't have the repair facilities, you don't necessarily have the extra materials, you don't have the staff to make changes and correct stuff. So you want to make sure that you're catching all the potential issues before you go out. And so that really put an emphasis on checking for, you know, does everything work? Do you have all the replacement parts? Are all the components in? Is everything plugged in before you start your voyage? And so that really, you know, kind of is where commissioning originated, but from there it's grown. And so it's not just about, you know, okay, is everything packed? Is everything there? Can we press the on switch? Does it run? It's also, hey, okay, you know, there's something weird going on here. Let's dig into it further while we're at dock. And then even taking that a step further, okay, we know the systems work correctly. What about the human systems? You have the crew been trained? Do they know how to work everything correctly? And so it's working out all the kinks before you're actually at sea and, you know, don't have those resources. So the formal definition, you can kind of skim over that. The way I really think about it in plain is in the gap between owners, engineers, various code writers, installing contractors, everybody involved in the project to make sure it works, right? And a big part of that is providing tools to catch issues early and ensuring that buildings are working the way we expect them to. Not just necessarily how they've been laid out on paper, but, you know, the common sense, you expect a building to be watertight. you know? And, part of that is not just going out and doing testing, but asking the stupid questions, checking to make sure the roof is complete. It's surprising how many times I go out on a site and I find that something just hasn't been plugged in. So you're doing that, and then at the other end, you're also acting as that experienced person to act on behalf of the owner, because projects, buildings, systems, they're complex, and getting more so. And so having that, person that's experienced, that's seen this sort of thing before, and has also, had a chance to see how different things can go wrong, that's a real benefit to owners. So obviously, a building is not the same thing as a ship, but this is basically taking that same idea and translating it to a building. We want this building to work properly when the owner takes it over. Once the contractors leave the site, it's a lot harder to make changes. It's a lot harder to make corrections. Once people have moved in, right, it's a lot harder to get access. You don't want to be opening up walls, doing whatever. So it's doing the corrective actions and finding the issues at the right time, and making changes and fixing things when they're easy to be fixed. I mentioned that building construction is complicated. So this is just an outline of some of the major stages in a typical construction project. How familiar is this to you, folks?
Pretty good.
Pretty, okay. So you've got this. I've got a brief outline here of the different people involved, and you can see it changes throughout. That's a big point. Every time there's a transition between a major stage or kind of a major party that's leading the process or leading their particular part of a process, you lose information. There's a drop in communication. There's miscommunications. To put this in perspective, I always sort of wondered why in hospitals there are certain staff that work 24-hour shifts. I always thought that's crazy, right? At the end of the 24-hour shift, at the end of 24 hours being awake, I know I am so tired and I'm not thinking clearly. Well, there's more than one reason for why they have that shift layout, but one of the big ones is that they found that it actually reduced the number of errors that were happening. So every time they had a transition from one, nurse team, one doctor, the patient's care team, there was misinformation, there was, a skipped dosage, there just was this gap. And crazily enough, that 24-hour period is where that balance between loss of information and people being too tired to function ends up falling. So kind of smoothing out these gaps between every time you change, involve parties, that's a pretty big part of commissioning. It's something that kind of gets overlooked a lot. Just to, I don't know, give you a worst case example, and this is a real project. I was commissioning a New York City Parks headquarters building. The financing of it got tied up, so instead of a 2-year time frame, it ended up having a 5-year time frame. In the course of those 5 years, the owner's contact changed several times. The architect retired. The engineer who designed the project got hired by a different firm. The mechanical contractor had 3 different project managers, and the lead consulting firm that did the energy modeling and really drove a fair number of the project requirements ended up going bankrupt. And so, if we look at these 4 parties, we've lost the main, person from much all of them, is keeping the original design intent and what the original project goals were, consistent. So fortunately, we were involved with commissioning, and I also fortunately was there for the entire period. But even if we had gone out of business or I had left with the company, the documentation that we put together, starting at the beginning and documenting, okay, these are the project goals. This is how the designer is going to meet those goals. These are some tests they're going to test to make sure that the systems installed actually meet that design, meet those original goals. Those was stayed with the project. And so there's some continuity that's being provided, which, yeah, again, often overlooked, but I think is a really key aspect to what we do. Systems, buildings, everything's getting more complex. And the systems in particular, right, we're pushing harder and harder for more and more efficiency. As we do that, the equipment that we use to heat and cool our buildings is getting exponentially more complicated. And it's just the more efficient we can get it, that's being done by cutting out waste, optimizing, tuning, really getting this to be as close to the margin as we can. And at the same time, the people involved, the owners, also the mechanical contractors, the installers, the vendors, equipment manufacturers, everything is becoming more and more specialized and compartmentalized. And so at the end of the day, we're moving more and more towards a situation where no one, and especially not an owner, is really able to encompass the entire project and have the expertise to really oversee it. Commissioning agents try and fill that role, even for owners that have the background and the experience. When you're in a construction project, there's just so much going on that you don't have the bandwidth to pay attention to a lot of these things the way you need to make it successful. And so commissioning agents' role there is to filter and highlight the information that the owner needs to know, give them the context to know what decisions they're making and what are the pros and cons, and then step back, let the owner make the decision, which may not be the same decision you would make, right? But every project, every owner has different goals, and respecting that. Okay, so that was kind of some definitions, some background. What's this look like in a little bit more of a concrete framework? Well, so there's some general steps, like early in the project, design and planning involvement. We're providing a second set of eyes during design. We take a look. We use some of our past experience to say, hey, this is something we saw in the other project and it didn't go well, or hey, this ended up happening and here's an easy way to prevent it. We're involved through submittal review. So when the equipment that's going to be installed gets submitted for approval, again, that's using experience with similar pieces of equipment, and also just providing that second set of eyes in case we're going to catch something the engineer might not, or we're coming at it from a different perspective. Often we're looking at things from not only a design and functionality, but also a maintenance standpoint. So this equipment might be great, but you can't access the inside of it. So if it breaks down, someone's got to, take the whole system out, drop the ceiling. A lot of times there's issues with filter access, which is probably the most common maintenance task that you need to do. So just like keeping that in mind, looking at it with a different perspective, a different set of eyes, simple thing can make a big difference in the person who's responsible for maintaining the building's quality of life. So then, we're doing that, working with the design team. We're also providing tools to not just the design team, but the contractors doing the installation. Things that will help prevent errors. So checklists are a huge one, but also just performing the role of being a communicator and checking in with them, translating things between engineering drawings, contractor feedback, what the owner's talking about and thinking about, and bringing the important stuff to the right people's attention. And then the probably the one that most people think about and the most visible portion of commissioning is testing systems. So figuring out ways to put a heating system, a cooling system, a ventilation system, whatever we're looking at, through all its expected modes of operation and making sure it's doing what we expect. Looking especially for unexpected system interactions, because a lot of the more basic things are already going to get caught. Like if a system isn't providing heat, you're going to know it pretty quickly. But if it's providing heat most of the time, and then when it goes through a defrost cycle, it blows cold air on people, that's something we can test, but you don't know to look for it up front. You're going to find out because people are complaining that they're getting icy air blown on them, and you don't know why. It takes a lot more to dig in and figure out what's going on. And then we come back. So we circle back usually 6 to 10 months after the, kind of the project is completed, and we see how the systems are operating in the summer if we tested them in the winter before, and the winter if we tested them in the summer. And we also see how they've, kind of settled in, because there's a lot of things that don't really come to light until after something's been used for a while. So this can sound awful lot like a code inspection or your standard inspection, and there are a lot of overlaps. The real difference, and it's almost a difference in approach and how you think about it more than a difference in a lot of the day-to-day activities, is commissioning is really intended to be proactive. We want to avoid mistakes instead of catch mistakes. So the more avoided mistakes, that's a win-win for everybody, versus catching something and having to fix it after. The sooner we can catch it, obviously, the easier it is to correct. But that just catching mistakes isn't the goal. It's avoiding them. A good way to think about that is if this class was a building, then the commissioning would be sort of like an open book pre-exam test. So like the final turnover to the owner, that's your test. How the building performs in the real world, that's like your final exam. That's what your grade's based on. We're the pre-test. We're open book, and you get to practice and you get to make mistakes, and that's okay as long as we realize what caused those mistakes and use those to tell us how to do it correctly for that final test. So it's a collaborative effort, and that's really important. I'll go into it. Traditionally, commissioning agents are hired by the owner directly. If you remember that whole list of different parties involved, well, I didn't have commissioning agent on that list, right, in any of the stages. And that's because commissioning agents are actually outside the normal construction chain of command. And that is great because it ensures we're a third party, we're impartial, there's no bias or kind of agenda other than to help the owner make the best decision possible. But it means that contractually, no one in the construction process has any obligations to do anything in response to something we say. So our role is really advising the owner and helping them and the rest of the team figure things out. A lot of times, I'd say 90% of the time, probably more, we're out on site doing some of these physical tests on equipment, and if we find something, everybody involved recognizes, hey, this is something that needs to be fixed, right? If someone's getting icy air blown on them when a system goes into defrost, that's not a sustainable system, right? And so we just transition right into, okay, how do we fix this? Where do we go from here? What's our best next step? Can we do this without having any cost or schedule impact? Can we even do this right now while we're out on site and then recheck it so we can just kind of move forward? We saw it, we fixed it, great. And that, you know, it's a little bit of a two-edged sword, not having, you know, any authority to actually say, hey, this is wrong, you need to change it. But I think in the end, it really helps because everything is this collaboration, and we are forced, you know, to be working through people and with people. And that's just the way to do it. Because when you start getting into a combative, hey, we need to do this. No, we don't. Yes, you lose focus of the larger goal, which is to have a system that works and meets the owner's goals. So, all right, key point, everybody has the same goal. That's how it works, right? We're providing the tools to help people do this. Let's get into what the tools look like. So if you look at that picture on the left, there's a set of louvers on a building, and everything looks good, right? The louvers. One of our tools is just looking. So when you looked inside those louvers, what we found is the packing material hadn't been taken out. Those were chock full of foam on the backside. So that's a real simple thing. Doesn't take any technical expertise to do that, but it does take having the bandwidth and the interest to go out and say, hey, you know, this was installed. Is it working? Is it performing the function of letting air through? Conversely, if we look in the middle, there's some things that just look wrong, right? This is an air handler, and right on top, there's ductwork coming across, and then the ductwork splits in half, and then comes back, connecting to the same end of the air handler. You know, that looks wrong. What's going on there? As best as I can tell, what they did was they couldn't fit the right size ductwork down into that intake, and so they split it up, you know, connected on two different sides. It looks wrong, but hey, it works. So that's okay. And then on the subject of doing things that look wrong, sometimes you have to do is do things that are wrong. So this picture there is combustion testing. We're testing to make sure that these boilers turn off when the exhaust is blocked. And so to do that, you stuff stuff in there. You simulate what would happen if we got a huge snowstorm, you know, and those got iced over or covered over, and you want to see those boilers shut off. So on a day-to-day basis, if you were a commissioning agent, what would your day look like? It would be somewhat split between office and field work, but a large emphasis would be on the office work, right? You're doing a lot of prep. It's kind of like the adage, measure twice, cut once. You want to do your homework and know what systems you're testing, know what you're looking for, have an idea of how you want to test them, and some contingencies in mind before you get out on site and you've got, you know, 3 to 5 different people waiting on you, trying to support you. That's you know, a real important part. I think the thing that kind of advances as you get to be more senior and more experienced is knowing how much prep needs to be done and how much flexibility and how much to, you know, leave up I don't know, up for debate, up for discussion once you get into the field. So that's kind of the big, like, hey, here's commissioning. You've got the vibe. You've got some of the, like, in practice, this is what we do. How are we feeling? Does this feel like a good level? Are we going too deep, too shallow? Do you want to hear more specifics, or where are we at?
We can continue this level. We need a better understanding of different steps involved, so it would be good to continue. Yeah.
Okay, the different steps. Perfect. Okay. let's skip over this. This is an example, physically, if we've got a damper, like the commissioning of that damper would be, we tell it to open, did it open? One aspect of that is that we don't, usually have just a damper. The damper is part of a larger system. And what we're looking at is that whole system. So we want to see how that system is acting as a whole. So extending that damper example, let's say when the system goes into occupied mode, you want that damper to open and bring in outside air to ventilate the space. Okay, so that's the next step of it is we've got a schedule involved. So we want to make sure that A, that schedule actually commands that damper to open, and then B, that damper actually opens. And then the third step of it would be, okay, do we have a set point that adjusts? Does opening this damper cause any other impacts on the system? Are we introducing too much outside air and exceeding our capacity of our heating system? That's kind of like the different steps. There's sort of a fifth level where you might say, okay, this one heating system that we've looked at, that's great. What does this look like in the context of the bigger building? Do we have a lot of other heating systems that are all starting up at the exact same time? Is that, putting too much of a draw on the electric grid or our boiler? So we're looking at as much as possible at the system level. We do want to drill down and make sure that the individual components are working, but usually that's something that we can see first at system level stuff not doing what we expect it to. The majority of commissioning, at least the visible portion of it, that's this testing. So going out, figuring out, okay, we want to see the system in heating. Let's do it. Let's change the schedule. Let's go for it. That pretty much happens at the end of a project. So once testing and balancing has been done, once equipment startup has been done, and once, ideally a little bit before turnover to owner, but once you've got your controls all tuned and set up, we use functional tests to do this. So those are tests, and we're looking at expected operating conditions and expected results. So, some big ones, occupied or unoccupied, heating, cooling, satisfied. That could be tricky. You want to check the failures, the alarms, any manual overrides, and then the maintenance. I mentioned that before. We have to usually figure out a way of simulating different conditions. So if it's the middle of summer and you've got a system that provides heat, or at least as part of its function provides heat, well, we need to figure out a way to trick that system into thinking it's winter. So that can be as simple as getting a cup of ice water and putting the outdoor air sensor on. Sometimes we'll use cold packs. Sometimes we'll use override from a control system and just say, instead of 70 degrees outside, you think it's 30. You've got to think about the other impacts that will have, though, because if you have a heat pump system, for example, and you tell it that it's 30 degrees outside, but it's actually 70, it's going to be more efficient, right? It's going to be better able to suck heat out of that 70-degree air that is 30-degree air. So you need to use a little bit of discernment about when you can override values, when you have to, trick a sensor into thinking something, and when you just need to come back when it's colder out. We also usually do a sampling approach when there's multiple pieces of equipment. So like a lot of classrooms have unit ventilators, and you know how many classrooms there are in schools. Well, we wouldn't go into every single classroom necessarily. We'd want to test enough so that we knew if there were any systematic issues, and then we'd want to get those corrected, and then we'd want to recheck. And every time we start seeing an issue, the number of units that we plan on rechecking increases. So you really, as a contractor, want to have as few issues identified early on as possible, because that reduces the number of systems and units that you're rechecking. What does this look like? So these can take a lot of different forms. We use something fairly simple, and it'll just have, the information you need. So who was there? When was the test? Are all the prerequisites, the things we expect to be done for the system to be ready to be tested, have those been done? Where are the set points currently? Because we're going to change a lot of things on this piece of equipment. We want to make sure that we're putting it all back at the end of the day, because we're going to walk off the site, and if we forget to put something back, the installing contractor or the maintenance person's going to get called the next day, and they're going to wonder why their system's been overridden into cooling in the middle of winter, right? So we need to document what the original conditions were, hopefully return everything there. And then just some spot checks of, like, is it on the appropriate vibration estimation? Is it plugged in? Does it have the clearance? Are there any visible dents and dings? And then we start getting into the functional tests. So that's on that third page there. And it details how we plan to simulate condition, what we expect to happen, and then gives us space for notes. Even if you don't end up using that exact process, having a process in mind outlined for how you would test something is really important. It's critical, because you've thought through how you would test it. That's your building block, your stepping stone to deciding how you're going to test the next thing, or how you need to modify that test. One thing I haven't really touched on, it's a little bit of a nuance, but commissioning checks moving parts and systems. And that leads to some interesting, kind of categorizations of things that do and don't get commissioned. So lights don't get commissioned. They're static pieces of equipment. Lighting controls do, because those turn on and off. Typically, you would not necessarily test the manual light switch, because that's considered, user driven. You would definitely test an occupancy sensor. Dimming controls kind of fall into a gray area between those two. There is a weird instance too, building envelopes. So those have a sort of specialized commissioning procedure. And you do sort of think of them as a system with moving parts. It's just really slow moving, right? And the moving parts are indoor and outdoor air temperatures, rain, other outdoor conditions. And so a building envelope commissioning agent goes through and does a lot of visual inspections, but then simulates those weather conditions as best they can. So with pressure tests and nozzle tests with rainwater, or spray tests, to see what the system's actually going to do. Another thing we do is pre-functional checklists. These are the things that check the non-moving parts. So this is a checklist we give to the contractors before we start any functional testing. And it's a combination of manufacturers' best practices, engineers' requirements, and just general best practices. A lot of the stuff that we put in these are things that the contractors would already be checking, but they're really useful because it makes sure that every unit has all of these things checked. They provide for the commissioning agent, they're a good indicator of when a system's ready to actually be tested. So when we come out and do the functional testing, and they're also kind of the first pass catch for anything that's going to be unsafe or damaged into the equipment. So an example of that would be making sure that the phasing to a motor is correct. Sometimes you can have the phasing incorrect, especially on like a 3-phase motor, run in reverse, and that can be really damaging. It is similar to a vendor startup checklist. It's like a heat pump. We've largely gone to accepting the manufacturer's checkouts instead of these because we want to reduce redundancy. We also try and limit these to things that are really important so that there's a minimum amount of documentation that is needed, because especially on some projects, getting these can be like pulling teeth. So that's kind of like the testing and the physical inspection part. Going back to the beginning where I was talking about, okay, where do we get the goals for this project? Well, that's something that gets documented in the OPR, the owner's project requirements. And this is basically the commissioning agent providing a structure, a template for the owner to, think about even some of their project goals. Often the goals that an owner has going into a project aren't very well verbalized. They're not even necessarily defined in the owner's mind. And so this is bringing all these questions up and getting an idea. I find that the best way to do this is actually through a workshop. Doing a meeting, having someone assigned to take notes, and just having people respond. When you try and just send out a form for someone to fill out, the responses aren't great. In response to this, there's a second document. This is the basis of design. And this gets filled out by the designers, the engineers, the architects. And it's essentially a narrative response. So these were the owner's goals. How are you meeting them? In, written form. And it's surprising how often this catches things. Often the owner's goal will be something that doesn't necessarily fall nicely into like a prepackaged system. So an owner may want, let's say, a pool, and they want a system that will heat it and clean it. And the engineer's like, oh, I can heat this. Why? That's great. Here's our heating system, and completely ignores the cleaning portion because that's a separate system, a different specialty, whatever. This is that back check to make sure that those things are getting carried through into the design, and then translated back into an understandable format. It's not the same level of details like a specification or a drawing, but it does capture the design intent. And we go back to these a fair amount on projects where, especially if there's been a gap or a delay, trying to determine, okay, what do we want to accomplish here? Commissioning specifications, those supplement the engineer's specification sets. There's generally between 3 and 4 specific sections that get added. There's a general section that goes in the front end, mechanical, electrical, and sometimes plumbing. Sometimes the plumbing gets included in mechanical, depends on the contract setup. It has general information, right? Contractor's roles, abbreviation. The general section will have a list of what equipment is expected to be tested. The mechanical, electrical, and plumbing sections, those are in each of the different contractors' divisions. So like 22 for plumbing, 23 mechanical, 26 electrical. They'll have some sample tests. They'll also have an outline with pass-fail criteria. So it's telling you what we're looking for in terms of performance. Often that's pretty basic. So does it follow the sequence of operations? Is a pretty good catch-all. But in heating, is it providing hot air and maintaining set point within plus or minus 2 degrees? And that turns out to be surprisingly difficult for a lot of systems. So it's spelling out, hey, open book test, right? This is what we're looking for. It also spells out who's expected to attend each of the testing events and who's expected to support it. It is important that the contractors on site and not just like the contractor's office, but the people involved in doing the work are aware. The specs, the drawings, they're great. On pretty much every project, we do a commissioning kickoff meeting. And at that kickoff meeting, we put together a commissioning plan. It covers basically everything I've talked about here. It defines the steps, who's involved. It gives you contact info for the different parties, lays a rough schedule, and also, says this is the equipment we're going to test. This is the responsibility. If things fail, this is the process we're taking. And sometimes that involves retesting. Sometimes it involves back charging for additional visits. We don't like to do that, but that's kind of the hammer that is kept in reserve to make sure that we don't just keep getting brought back for the same issues over and over again. It's important that the people doing the work know about this, partly because it gives them the cover to say, hey, to their main office, I can't get pulled off right now. I got to finish this. Someone's checking it. I've been told by multiple contractors that they've, used me as the excuse to, stay on a job and actually get what they're working on done. It's something they appreciate. You're also providing that back check for them. You're helping them minimize callbacks. So it's a good process for everybody, but it doesn't help if they don't know what's happening, because then they're just doing business as normal. Commissioning plan, we talked about this. We talked about this also, about the commissioning agent's role as a third party, right? Outside the normal chain of command. We can't force people to fix things. We report to the owner, but really our reports basically go to the entire project team, because open communication is really the most effective for what we're doing. Some other activities that we do often help with owner training, not necessarily putting it on, or even, like providing critiques or feedback, but just making sure that happens, making sure that it's useful. So that can take the form of sitting in on it and taking a video, taking good notes so that people don't have to worry about doing that and can really just pay attention to what's going on. Again, asking the stupid questions, right? Being the person that doesn't care if someone thinks they're stupid if you say, wait, what was that you said? How does that work? And then, of course, we produce a commissioning report. That report, includes a couple things. The biggest part of it is just, here's what we found. Every site visit we do, every time we do a review, there's a smaller report that goes out. This is a compilation of all those, and at the beginning, there's a summary of these are the big picture items. So includes contact info for everybody on the project. So you can go back and you can say, hey, who did that install? Who do I need to talk to about this controls issue that's just come up? It includes copies of the functional test reports. So usually that includes actual raw functional test forms. Sometimes we'll do the functional testing with the owner's maintenance staff there, and they're able to do it on their own later. And so this is a great way to make sure your equipment's still working the way it's supposed to, and troubleshoot things. It can also include training notes. For any code required commissioning, it will include a review of the as-built and O&M manuals. And for more extensive commissioning, especially lead enhanced commissioning, it would include design review notes and some other things.
Wait, can you hear me?
Yes.
So while you're explaining aspects of the report for commissioning, can you also explain a little bit about if there are standards and guidelines for commissioning, and what organizations are responsible for this?
Yeah. So LEED has a couple different levels of commissioning. The current version, LEED 4 point whatever, has standard, they call it fundamental commissioning. And that is a prerequisite for any LEED project. So if you have a LEED building, it has to do this commissioning. On top of that, you can get a couple of different credits. You can get one for building envelope commissioning. You can get some for enhanced commissioning, and that basically extends the commissioning process out earlier into design, further out into seasonal testing, and also involves more formal submittal review. And then there's also an O&M or ongoing commissioning point that you can get as an adder to that, and that uses monitoring based equipment, so like different meters and sensors that get installed as part of the project to check back on the project and do trend reviews, making sure that things are still working right within the following year plus of use. There's code commissioning. I'll mention that a little bit later too, but both New York City and New York State have adopted portions of the International Energy Conservation Code, and that includes a requirement that buildings over a certain size, and it's not actually square footage, it's based on the heating and cooling system capacity. But basically it's between anything over about 20,000 square feet will typically require commissioning per code. That is specifically looking at energy using systems involved with heating, ventilation, air conditioning, and depending on if you're in New York City or not, renewables. And it doesn't actually require any design phase involvement. It does require that commissioning is mentioned, we'll call it, in the construction documents. So there needs to be a note telling the contractors that commissioning is going to happen. It requires a commissioning plan. It requires a review of the testing and balancing report and functional testing of the mechanical, electrical, and plumbing systems, as well as two reports actually, a preliminary, which is supposed to be issued or available for review at the time of final code inspection, and a final, which there's different durations depending on if you're in New York City or New York State, but for New York State, within 90 days of the issue of the preliminary should be released, and that final is supposed to have the resolution to all open items identified in the preliminary. You can do seasonal testing, which can allow you to extend further. And I do have to say, I have not found anyone that has been really strictly enforcing the timetables on those. But that's the code.
All right, so before moving on to why commissioning, if you agree, we can make it a little bit interactive. So I ask here to see a question about overview of commissioning and the general description and steps and parties involvement that Nate explained. Any questions in the class or online? Fahad has a question.
Commissioning required by the building codes.
So one of the students, Fahad, is asking if the commissioning is required by building codes or not.
Yes, it's required by the Energy Conservation Construction Code for commercial buildings over a certain capacity, and it's a new construction requirement. So there are certain existing building rehab projects that may not require it.
Okay, great. If there is no more question, we can continue. So I know you have a lot of slides explaining different aspects of commissioning, but if we can get into the experiences, projects, examples, that would be great.
Sure. Yeah. So this is like the pitch to you folks, right? Why commissioning? Why would you want to be a commissioning agent? I mean, I think it's fun, right? You get to make an impact. You get to develop a lot of different skills, and not just hard engineering skills. But to me, I think the last point is the one that resonates. This is almost more like a sport or a performance in some ways than anything else I've encountered in engineering, because it's got that aspect of practice, and then you go out for a game, and you can't do just one and not the other. If you mess up when you're in the field, that means you lose, but if you haven't done enough prep, if you're unprepared going out, you're that much more likely not to perform well. So it really, I think, brings together that little bit of pressure as well as that preparing, and a lot of non-technical and technical skills, including straight up physical and mental stamina. Just being out on site and being able to continue thinking through different things and different unexpected things all the time you're out there. So that's my pitch for why you might want, why other people want to have commissioning. I think it's pretty clear it's beneficial to building owners, just in terms of improved operations, avoided issues and having this trusted advisor. But there's also a significant cost benefit. So take these numbers with a grain of salt because they're from two studies that include at least a fair number of self-reported numbers from different commissioning agents. But if you can see the numbers, the payback periods, we're talking 1 to 2 years, maybe up to 4 years, which is that's low. That's like replacing incandescent light bulbs with LEDs. And the savings that you're looking at are on the order of something like a boiler replacement. Like, so this is a really cost-effective thing to do. And I think that's what's driven a lot of the inclusion of it in more recent codes and standard practice. So again, it started with chips. Walt Disney actually started including it in their standard practices. There's an ASHRAE guideline. And then LEED added it, and that really drove much broader awareness. Enhanced commission was added, and now we've gotten to the point where a base level commission at least is required, by code for most buildings. I know for New York State, New York City, certainly, but especially because it's the International Energy Conservation Code that's bringing this requirement in. I wouldn't be surprised if it's, required for most places nationally. I will say, commissioning is not a great fit for smaller, simpler buildings. You just don't have the same level of potential savings and issues. So there has to be a balance of costs versus the avoided risk and the benefit. And it's also not for everybody. This is actually a list of criteria that I look for in staff at Tatum when we're evaluating people that might be good at commissioning. I'm not going to go through it, but I think if you're thinking, hey, this seems sort of interesting, these are the sorts of things you might want to pay attention to in yourself and think about working on. Okay, so questions? No? Okay, so let's go ahead.
Yeah, go ahead. The findings that you generate from your test reports, are those often retained long periods of time as like in databases, or are those generally like for short-term use?
They're not necessarily, so it depends what you're talking about, long periods of time. The goal is that they get corrected. So the shorter these issues are maintained as issues, the better. But the reports that we put out that document what we found and how it was corrected, those get turned over with the building, documentation, and they stay with us. I was just contacted a couple months ago by a project that we commissioned about 7 years ago, and they were having problems with their heat pump system, and they had been looking all over for solutions and came across our commissioning report and said, oh, the testing and balancing never actually was done correctly. And there was this oddity we noticed on this one compressor. And they kind of chased that back. And apparently, it turns out there's some issues with heat pumps when they're not getting the correct amount of flow. They can do some weird things, resulting in some seasonal burnout. And so they called us in and were like, was this actually what was happening? And we're like, I don't know. I mean, like, yes, that's definitely what we were seeing at the time. Let's bring in the manufacturer, and we were talking with LG reps and getting to the bottom of it. They ended up rebalancing the system, and so far that seems to have resolved the issues. So yeah, I mean, I think that there's useful information there, especially, I know, for example, Cornell has a practice every 4 years they go through and they recommission every single one of their buildings. They just have a rotation going on. And so when you've got that sort of setup, the functional test that you did 4 years ago, you don't necessarily have to recreate the wheel, right? You can rerun that test and look for changes, look for modifications. Yeah, does that answer the question?
Thank you.
Okay, is there any other question before we move to the next part, which is the fun examples, I believe? If there are no more questions.
All right. So let me just give you an example. This is a building that we looked at. I'm going to walk you through some of what we found, and then we'll do a bit of a test. I'm going to give you something else from the same building. We're going to see what you can find. So this will show you the process a little bit, and then we'll see what you can do with it. This is a fairly small office building. One thing that was cool about it is that it had occupancy controlled heating and cooling. Pretty awesome, right? How many of you are familiar with VAV systems? No? Yes? You folks know what that is? Okay. Basically, it's a damper that opens and closes depending on if you need more heat or cool air. What they did was they tied the control of that into the occupancy controls. This was a really cool idea, but once we started, once the building was built and they started using it, they started saying, "Hey, it's really cold in the morning. What's going on?" Turns out no one was in the office when the system was supposed to be preheating the space, and so the occupancy sensor controls were setting back the set points, and the space never came to temperature. And air is great because you can move it and you can get kind of a warm space, but the objects in the space, once you've got like thermal mass or something like a concrete floor, it takes a while for that to heat up and for it to actually feel warm. I know if any of you have like had the experience of going into an ice rink and sitting on the bleachers, and even if the air's relatively warm, you're just getting the heat sucked out of you by that cold concrete floor. They, once they figured out what's going on, they were able to program the software. They actually had to upgrade the software, and were able to put in a second set points for Eastern warm up. But that's one of the things we look at with something a little bit more complex like this. The other thing is you've got nuisance triggers of the occupancy sensors, right? So someone walks by your office and the sensor picks up that motion and turns itself on. Well, it's not that big a deal when it's a light, right? But all of a sudden, you're not just turning the light on, you're changing your set point for your space, you're kicking your heating system up into another gear to bring that space up to temperature. And the owner was seeing it and saying, yeah, sometimes the lights turn on, we just manually turn them off when we leave. But those occupancy sensors were still going on and off. And so looking at the trends, we were seeing this crazy, spike, dip, spike, dip, spike, dip because of these, nuisance triggers. The really easy solution, you just mask the portion of the sensor that's facing those open doorways. And then you got into a little bit more involved, I guess kind of systematic type things. So for every room you have, you've got an occupancy sensor, right? It doesn't work if you've got 2 rooms sharing an occupancy sensor. But the traditional design for a heating and ventilation system is that multiple rooms will be on the same zone. So you'll have a thermostat in one room and both rooms will share that control. Well, how does that work when you've got occupancy sensors that are also controlling that thermostat? Setting the system back, closing out the ventilation. The idea, the goal was that whenever any of those rooms attached to a certain VAV unit were occupied, the system would treat it as the entire zone's occupied, bump up the set point. But if you look, so this is a schematic of the VAV box and the controls. Well, so the VAV box was supplied by the mechanical contractor. The controls contractor did the thermostat and the controls wiring, and the electrical contractor did the lighting occupancy sensors. And the combination of all 3 of those things, there was a bunch of miscommunications. One of those was that instead of wiring the lighting controls up in series, or in parallel, where if either of them triggered, it would send the, hey, this has been triggered signal to the VAV box. They were done in series, so both of them had to trigger. So you can imagine how this can cause problems if someone goes to lunch and their occupancy sensor turns off, leaving their neighbor cold, or someone doesn't come in until 10:30 in the morning. Neither of the two offices connected would trigger on into full heating. So again, fairly simple correction, but it had to be identified. So what if we look at another system in this building? This is the test portion, and I'm going to characterize it as a test, but it's not for me, it's for you. So this is a chance for you to see if this is something that you might be good at or you're interested in. So same building, small office space. There's an air handler. That's the blue box here. It puts out with the blue arrow heated, cooled air mixed with some ventilation air to the different zones. Each of these zones has a VAV. There's, if you look at the green arrow, there's outside air coming in, and this red arrow shows exhaust air being exhausted. It's a pretty simple system. This is what we were looking at with the controls graphic of it. So I'm going to just kind of explain what we're looking at here. But while I'm doing that, hopefully you can see the numbers well enough. See how many things you can figure out that don't seem right here. And a real good start there is just looking at something. This requires no technical knowledge. Just what principle of physics are we violating here, right? Conservation of mass, thermodynamics, common sense. So what we've got here, this is top duct return air coming in at the right, exhaust air from that same stream goes through a fan. There's a T, and there's two dampers, one going out to the exhaust air, one that would bring things back and circulate through on the supply side. That connects there on the bottom. You've got outside air coming in at the bottom left, another damper to control the flow there. You've got a filter, a heating coil, a cooling coil, and our supply pan, and that goes out to the space. Does anybody see anything that's jumping out at you as, hey, this doesn't make sense? Yeah?
Can you state a little bit louder?
I'm not sure if this is right.
No, that's fine, just,
Yeah.
Supply air temperature and the return air temperature are different, and I don't know why, to me, I thought those would be the same. But,
supply air
Okay.
temperature, return temperature are different. What do you mean by that?
there's, the supply air temperature looks like it's at like 61.2 or something.
61, okay,
And the return air temperature, or at least I think it's return air temperature, looks like it's like 73.
73, yeah.
Yeah, I thought those would be the same, but maybe I'm wrong on that.
Okay. You're on the right track. Those actually, return air is going to be your typical space temperature for a VAV system. I didn't explain this thoroughly at the beginning. You actually want it to be either hotter or cooler than your target space temperatures, because you're controlling that space temperature by opening or closing that damper more. And so you're injecting, cooler air than you want, but controlling the amount if you want it to cool down a space. So like you mix, 60-degree or 55-degree air with your 70-degree room air to bring it down to like 68. But you're looking in the right place. So that's supply air of 61. Do you see right below it? We've got our set points.
Oh, damn. Like, oh, yeah.
And we're not meeting our set point, right?
Yeah, that's
Why do we think that is?
Is this not? Is this not? Is this?
No, I'm talking about just the numbers in general. I can't get into that.
That's 55 degrees. Right. That seems low
Let's see if
for,
I can.
Can you?
Here we go. I can zoom in.
that point seems really low.
So, one answer here is the set point is pretty low.
It is a little bit maybe, but the unit should be capable of doing it. I'll give you that. And again, this set point being low, that's a direct result of the way the VAV system's set up. The other thing that's at play here, like normally you wouldn't necessarily see a 55-degree heating set point. These spaces all had perimeter fin tube radiation for heat as well. And so this air handler was primarily delivering cool and ventilation there. So, but you know, I did tell you the unit should have that capacity. This DXC, this is our DX, our air conditioning system for it, right? And we can see that both stages are on and our speed is at 100%. So if we've got the capacity and we're in full cooling, but we're not dropping our temperature down, what do we think's going on?
Both cooling and heating.
Yeah. Our hot water valve is 100% open.
I think both are on at the same time, so the air is, I don't know, it's heating and then it's cooling down. So.
Yeah, it doesn't know either. What happened there is that the hot water valve opens automatically when you have a certain discharge air trigger. It's a freeze safety. And so once you drop below a certain discharge temperature, it says, oh no, we might be close to freezing this coil. And so let's throw an alarm and open our hot water coil, and it should turn off the valve or turn off the fans. Only part of that sequence worked. So the only part that worked, it didn't throw an alarm, it didn't turn off the fans, it just opened the hot water coil. But it stayed opened up, and so this is how it had been operating for weeks. And it was getting fairly close to the set point, close enough that we weren't getting real comfort complaints. So that's a big first one, right? Hot water valve, 100% cooling mode, and both stages of our compressor were on for cooling. Does anybody see anything else? I know this might be a little small. Take a look over here. All right, so I'm going to help you with some acronyms. EA is exhaust air. MA is mixed air. RA, return air. OA is outdoor air.
I think the air from the outside is exhausting or something. Because
Something's going on. Yeah. So our minimum flow that we're shooting for, this minimum flow is our set point, is 1300 CFM, and we're getting just under 300 CFM. So something's going on there. This does say that our damper is 100% open, so should be pulling through. And our return air damper is supposed to be 100% or 0% open, so fully closed. So this is starting not to make too much sense. Yeah, so there's that. The other thing that we can look at is, right, we've got this 300 CFM of outside air. We've also got a reading on our supplier side. Those numbers don't add up, do they?
That is a massive. Yeah, it's losing a lot of.
Yeah. So if we're thinking about principles of physics that we're breaking here, right? We're somehow generating air from nowhere So that's a pretty big one. So what was going on? Remember that picture I showed you earlier about the outdoor air louvers? This is that same project. They just had styrofoam packed all through them. No one had taken it out, so they were getting no ventilation there. We talked about the low limit safety, right? And then inside remember we were looking at, said the return air damper was fully closed. Well, it said it was closed, but if you actually looked at it, it was 3 dampers, and they hadn't really calibrated them. So when 1 or 2 of them were actually kind of closed, the third one had this gap. Now, that's not a lot. That's not a big gap for that much air to go through. And this thing was whistling. And so that you're at a little bit of a disadvantage because you had to try and figure this all out from the screenshot. But that's the sort of thing that you're going to be able to like say, hey, something's going wrong here. Okay, let's dig into this further. Let's see. I'm looking at our time. I'm actually, well, let's open up for questions. Any questions?
So any questions? There are no questions, Nate. Yeah.
Okay, I'm going to skip ahead to a short example then. We'll do one more.
5 minutes.
Okay, this will be perfect. Very similar graphic, right? It's an air handling unit. And what I want you to pay attention to is right up here. They have a flow measuring station, and they've got speed control in their fan. And the controls are set up to, adjust that fan speed to maintain a certain flow rate. Well, here's what we have for trends. These are collected automatically by the building control system. Measured flow is this blue, and the set point is this green. So where are we seeing here?
Flows fluctuating a lot above and below the set point.
Yeah, for sure, right? What we've got is hunting. This is kind of a classic example of it. Right here is where it got fixed. And why? Well, the way I think of hunting, right? It's like, imagine driving your car, but you're driving it with like a foot jammed on the gas, jammed on the brake, jammed on the gas, jammed on the brake. That's how the system's operating. It's not like going into cruise control at all. This is like, real not efficient driving. You're like stop and go traffic here. What's happening on the control side? I don't know if anybody's done control logic or PID loops or anything, but it's basically overreacting. It's seeing that it's off from set point, it ramps up, it shoots past set point. It sees it's above set point, it drops itself down. So it's always chasing. The cool thing that we can see here, so we actually had fan power consumption trended as well. And you can make kind of an argument about, okay, my car is less efficient if I'm jamming on the brake, jamming on the gas, in terms of like, how does this impact efficiency? But it's not just like, the comfort issues of having your air temperature going all over the place. There's a clear decrease in the energy that the system used once that hunting was solved. Alrighty. So we're going to skip the more involved example. I think that's it for me. Again, last chance for any questions. I can give Cheyenne my email address, and folks can reach out if they've got anything else to do.
For sure. If there is no more question here, we can thank again Nate for taking the time. Thank you, Nate. I will end the session. I'll catch up with you later on. Okay. Thanks again.
Sounds good. Yep. Bye.
Bye.